Discover what's possible when we think research at Case Western Reserve University.
Being freed from a ventilator. It is the top wish of people with spinal cord injury.
Remarkably, walking is not among the top of the list, nor is hand function. What's most important for people with high spinal cord injuries, of course, is breathing.
A new discovery at the Case Western Reserve School of Medicine holds new promise. Jerry Silver and his neurosciences team have biologically restored breathing in an animal model to an extent of which has never before been documented.
In my lab, we've used a relatively old technique and a relatively new technique to bridge a lesion in the spinal cord.
The so-called old technique is the use of nerve graft, which can restore function in arms and legs. But nerve grafts haven't worked in a spinal cord until now.
After injury, the spinal cord in the adult develops what we call a glial scar. Many years ago, we discovered that the scar is embedded with inhibitory molecules that block nerve growth.
The researchers found a way to get rid of this scar tissue with the use of a bacterial enzyme. The new technique involves bridging the spinal cord injury with a peripheral nerve autograft and injecting both insertion points in the spinal cord with the enzyme.
The use of the enzyme, that's helped get the nerve fibers out. And we were amazed that once they get out, how well they can reconnect. And the spinal cord can just figure things out and restore really beautiful functional breathing patterns after injury.
3 months after the procedure, tests recording nerve and muscle activity in the animal model showed that 80 to more than 100% of breathing function was restored.
So this is true biological long-distance regeneration that restored function, which is robust and long-lasting.
Learn more on how Case Western Reserve University thinks beyond the possible at case.edu.